Hello and welcome to Aditya classes, where we have been talking about game theory these days. Now in last lecture when we met, we solved a game of size 2 by n and m by 2 using method of subgames. Now we have taken the very same examples that we took in previous lecture using method of subgames. Now we'll solve these two games using graphical method. So same games can be solved using graphical method also or method of subgames also. So let us see how we go ahead. We'll take up the first question over here. Now the concept of graphical method is that you select the player with only two strategies. Here A is having multiple strategies, but B has only two strategies. So B's strategies would be plotted here. Now remember that this time I'll be plotting strategies of B. This is very important to understand the concept, that I am plotting strategies of B. So this becomes strategy of B1, this becomes strategy B2. So we have B1 and B2. Now the values are ranging from 6 to -1. So what I'll do is I'll plot a scale over here which will range from 6 to -1. So let us say we have a -1 over here, leaving me with a 0 over here. Then I can proceed further with 1, 2, 3, 4, 5, 6, 7. Taking me to 7, 6, 5, 4, 3, 2, 1. So we have 1, 2, 3, 4, 5, 6 and 7. Because my values are ranging from 6 to -1. So 6, this was supposed to be 7, 6, 5, 4, 3, 2, 1, 0, -1. So we have 0. Under that 0 we have negative values, -1, -2, -3 and so on. We have 0 and above it we have positive values 1, 2, 3, 4, 5, 6, 7. So what do we have? B1 6, B2 -1. On B1 6, on B2 -1. B1 is 6, B2 is -1. B1 is 6 and B2 is -1. This becomes my first strategy for A. That is A1. I have plotted A1 as 6 and -1. This is my A1. Then we have A2 with 0 and 4. 0 on B1 and 4 on B2. 0 and 4. Here we have a 0 and then there is a 4. This is my strategy 2. A2. Then there is A3 with 4 and 3. 4 and 3. This is strategy A3. Now this is how our graph looks like. Important thing is you need to understand that this graph has two important areas. We have a strategy like this, then there is a strategy like this, and then there is a strategy like this. If you have a look at this graph very carefully, you will observe that there are two segments. This is one segment. Then there is another segment. We have two important segments. Then there is another segment where all strategies are intersecting each other. Now if I have a look at these two segments, none of the strategies is in this within this segment. Yes, strategies are creating boundaries for my segment, but none of the strategies is there in my segment, even here. So it is always very easy to select our segments. You may have n number of strategies. You may have a plot of strategies like this. So my segment becomes, this is my upper segment, this is my lower or minimum segment. This is what you have to identify. In this graph also, we can see that we have one segment we have another segment. Of these two segments, one is of importance for me, depending on whether we have plotted this game for B or whether we have plotted this game for A. So we need to select the segment which is important for me. So if I have a look at this game, it is plotted for B. Now, B selects strategy which is minimax. If you remember our earlier lectures, the strategy selected by A is that of maximin. Maxi min, that is maximum from minimums. And B selects a strategy of minimax. Minimax is minimum from maximum. So, the two areas that we identified, this is maximum area and this is minimum area, which is obvious. This is maximum values, these are minimum values. Now, because this game has been plotted for B, that is B1 and B2 strategies have been plotted, B plays with minimax, that is minimum from maximum. Now, this is the maximum area. If you see, this complete area is the maximum area. From maximum, minimum from maximum. So, B will be selecting minimum value from this maximum. From this complete maximum, what is the minimum value? This is the lowest point of this complete area. If you wish to understand what is the lowest point, you put a drop over here, drop of oil or water over here. So, that drop will scroll down here, it will come here, it will come here and it will stop at this point. It will not move any further. Even if you put that drop of oil over here, it will slide down and wait here. It will settle down over here. So, that drop will drop down to minimum level in this maximum area. B plays minimax, minimum from maximum, from this maximum minimum point. Which are the two strategies that are intersecting at this point? If I see, the two strategies intersecting at this point are A3, this is A3 and then this is this strategy which is A2. So, this A2, A3 will be giving me my best solution. This is what graphical method can do. Now, in method of subgames, I was making all these combinations A1 against A2, A1 against A3, then A2 against A3. But graphical has straight away given me two best strategies, that is A2 and A3. Now, you can go ahead and solve them. We have A2 against A3 with B1 and B2. So, my payoffs would be 0, 4, 4 and 3. You can check if it has a saddle point. If it doesn't have a saddle point, we'll go ahead and solve it using oddment method. Difference of 4 and 0 would be 4, difference of 4 and 3 would be 1, 4 and difference of 4, 3 would be 1. So, value of game would be, let us take this combination, 1 by 5 multiplied by 0, 4 by 5 multiplied by 4 by 5, giving me 1 by 5 multiplied by 0 plus 4 by 5 multiplied by 4, giving me 16 by 5. With strategy for A, A2, A3 is here, A1 is out. So, A1 is out, A2, A3 strategy is 1 by 5 and 4 by 5. Strategy for B is, there are only two B's, B1 and B2, so there will be 1 by 5 and 4 by 5, no zeros. So, we can see that, if you remember our previous lecture, this took a long time. First we made A1, A2, then we made A1, A3, then we made A2, A3, then we made a comparison. Here you plot your graph, you get straight away your best combination. This is my best combination, this is my value of game, and these are the strategies suggested for A and B for game 1. Next, let us go ahead and try and solve this second game using graphical method. Graphical method and method of subgames. These are the two methods that are used to solve games of size 2 by n and m by 2. Now how do we get size of 2 by n or m by 2? We get a size of 2 by n or m by 2 either by reduction. That reduction could be through pure dominance or average dominance. So if your game reduces to a size of 2 by n or m by 2, then you can go ahead and solve it using either of these two techniques. The two techniques being method of subgames and graphical method. And yes, there might be cases, there might be scenarios where you are directly given this kind of game. So you can directly go ahead and solve it using graphical method. Now in this case, A1 has two strategies, A1 and A2. B is having multiple strategies. So this game will be plotted for A. So let me plot strategy A1. Let me have strategy A2. Then our numbers, our payoffs are ranging from lowest to -3 to maximum 2. So let us have zeros. You can have -1, -2, -3, 1, 2, 3. 3, 2, 1, -1, -2 and -3. 3, 2, 1, -1, -2, -3. Yes, a word of caution. I have seen students doing this mistake. They make zeros, they put the marks, and we very well know that it was a 0, 1, 2, 3. So now, while writing, what they do is they write 1, 2, 3, -1, -2, -3. This is mistake. It should have been starting from 0, 1, 2, 3, -1, -2, -3. So this is a word of caution because I have seen students creating this mistake, doing this mistake, making this mistake. In any case, I have my strategies A1 and A2 ready over here. B1 is 1 on A1 and -3 on A2, -3 on A2. This is B1. Then we have B2, which is 0 and -2, 0 and -2. And this strategy is B2. Then we have -1 and 1, -1 and 1. -1 and 1 is B3. Then B4, 0 and 2, 0 and 2. This is B4. Now, this is a game for A. A takes maximum, that is maximum from minimum. We have two areas. This is one area, this is the second area. This is maximum area. You can take minimum from maximum. This is minimum area. So you can take maximum from this minimum area. A takes maximum from minimums. So this is the minimum. You need to take maximum. Where is that maximum in this area? If you see, this would be the maximum point of this area. How do we understand this? How do we visualize this? You leave a drop. You leave, suppose we have water filled over here, you leave a bubble. That bubble will climb over here, it will hit this spot and it will climb further to this point. You leave a bubble over here, it will hit this spot, it will come here, it will come here. So either ways, wherever you leave that bubble, it will travel to the highest point. This is the minimum area from maximum. Maximum from these minimum areas. This is maximum area. And this is. If it were B1 and B2, for B1 and B2 it would have been minimax, minimum from maximum, maximum, minimum. If it were B1, B2, then this would have been my ideal point, but it is A1 and A2, so A1, A2 will take maximum from minimums, minimum area, maximum. What are the two strategies intersecting at this point? We can see one is B3, another one is B2. This is B3, then the other strategy at this point is B2. So you can go ahead, write this subgame. Now what this strategy does is, it gives me the best subgame possible. So it is giving me best subgame possible as B2 and B3. I get B2, B3, A1 and A2. Of course, A had only two strategies, B2, B3. So it will be 0, -1. And then we have a -2 and 1, -2 and 1. You can check if it has a saddle point. If it doesn't have a saddle point, we'll go ahead and solve it using oddment method. You can check it doesn't have a saddle point. Difference of 0 and -1 would be 1. This would be 3, 2 and 2. So strategies would be 3/4, 1/4, 2/4 and 2/4. Value of game, we can take this combination 3/4 multiplied by 0, 3/4 multiplied by 0 plus 1/4 multiplied by -2. So this is 0. I get value as -2/4. And then strategy for A would be, A is only A1 and A2 in second game. In this game, A1 and A2 would be 3/4 and 1/4. And for B, we have multiple options. B1 is gone, so it is 0. B2 and B3 are 2/4 and 2/4. B4 is again gone. So these are my strategies and value of game for second game. Now if you remember previous lecture where we solved it using method of subgames, we had so many combinations. We had B1, B2, B1, B3, B1, B4, 3 combinations, 4th combination, 5th combination, 6th combination. We checked 6 subgames to find out best subgame. What graphical method does is, it gives you your best subgame directly. So this is the idea of graphical method, of solving 2/n and m/2 games using graphical method. Yes, at times it might so happen that you get a situation where you have a distribution like this. Now, depending on what is written over here, if we have A1 and A2, suppose if I have A1 and A2, so it is a game for A because I have A1 and A2. A selects maximum from minimum area. This is the minimum area and this will be the maximum point. So if you get a graph like this for strategies of A1 and A2, then yes, definitely I have my best point at this, and you can call these strategies as 1, 2, 3, 4, 5. My solution would be first strategy and third strategy, A1, A2, B1, B3. If it were a game for A1 and A2, but what if it were a game for B1 and B2? What if the strategies were B1 and B2? In that case, our solution is minimum from maximum area. This is the maximum area and I need to pick the minimum in this. Now, if I select this minimum area, there are 3 strategies, 5, 4 and 2. 5, 4 and 2. 3 strategies are intersecting at that very same point. Now, what do we do? In such case, what you can do is, at least a game with 5 strategies has been reduced to a game with 3 strategies. From here, you can go to method of subgames and you can select your best return game. So this is the idea, that we have a method of subgames, we have a method of graphical method. Definitely graphical method is superior to method of subgames, as it gives me one best subgame. But it might so happen that you get an intersection of this kind. In such situation, I am not getting only 2 games which I can solve, I am not getting only 2 strategies which I can solve using oddment method. Rather, I am getting this is for B1. So rather, I am getting A2, A4, A5. Now, if you are getting 3 strategies, then you are again stuck. You cannot solve it using oddment method. So in such cases, what you can do is, you solve your method using you solve your game using graphical method, and from here you can pick these 3 strategies and form subgames. The subgames would be A2, A4, A2, A5 and A4, A5. So this is a mix. Best is graphical, but if graphical lands you in such a situation, A2, A4, A5, then you can use subgames. And yes, you use the subgames only on A2, A4, A5. So this is the idea of method of subgames and graphical method. Next time when we meet, we'll pick up some more methods of solving unsolved games or unstable games. Stable games are solved using saddle point. But what about unstable games? So we have advanced from unstable games, from stable games to unstable games of 2 by 2. Now we have increased our range from 2 by 2 to 2 by n or m by 2. And next time when we meet, we'll increase our range further using some more methods. So this is it for our present discussion. Until we meet next time, do take care. Thanks for watching. Bye-bye.